Okay guys, so I'd like to talk about tolerancing, and we've covered a little bit of it in measuring, where we were talking about tolerances and how they are applicable in your trade. And I showed you one of them, which is runout. So as millwrights, we deal a lot with runouts. We have to check for runouts when aligning equipment, aligning shafts, and fitting hubs or gears. We need to find out the runout. So I showed you how to check runout using a shaft with a hub on the measuring card. So you all saw how it's done. I put dial indicator on the end of the shaft, and I rotated the shaft manually by hand, and then I was able to see the difference in the dial indicator reading. So I set dial indicator at 0 first by moving the bezel, and then when I rotated the shaft, it showed me the runout. So if I was checking that shaft again, and I found that runout is so that runout, I believe it was about 10 to 15 thousandths of an inch. Total indicator runout it's called, or TIR. Total indicator runout. You need to memorize this term because you will be coming back, and this will be mentioned in second and third year. So in this case, if I had 10 thou runout on that shaft on the measuring card, I'm well below the tolerances, because, for example, this shows me that the runout, maximum runout, is supposed to be 50 thousandths of an inch, so that's acceptable. Second measurement I would like to talk to you about is perpendicularity or squareness, and this is important as well. So surfaces have to be perpendicular, sometimes square to each other to be for good alignment. Okay, so the symbol for perpendicularity is right here, so you can look in the manual and see it. There's a datum to measure off, and maximum tolerance in our case is 50 thousandths again. So I'm going to use an angle plate, just like in the example here, and I'm going to measure perpendicularity or squareness of this face. So that face is supposed to be within 50 thousandths of an inch, so I'll see if that's the case. So for my measurement, I'm going to use the height gauge, and I just installed the dial indicator. So this is called finger dial indicator. I'll see if you can look at it. Yeah, so dial indicator, it's got bezel again, adjustable bezel that I can set 0 in any plane, and then it's activated by the finger here. So when I move the finger, push on the finger, pull or push, then the arrow or the needle moves. Okay, so I'm going to put that dial indicator on, finger dial indicator, so that's not a plunger. And what I'm going to do is I'm going to measure the squareness. So I need to make sure that with this squareness is within 50 thousandths of an inch. So as per datum here, so this becomes my datum again, the surface plate, and then the this surface is the one I'm measuring. So I want to see if it's, yeah, okay. So I'm gonna bring my dial indicator with the handle all the way down to the end of the stroke, and I'm gonna zero dial indicator. I'm not sure if you can see it or not. So I'm gonna bring it close to the surface. I'm gonna push on the needle. So right now the needle moved a little bit, and I'm gonna zero dial indicator by moving the bezel, and then I can set 0 on the height gauge, so my datum becomes 0 and 0 plane here. Now I'm gonna bring the height gauge up and over. I'm gonna be measuring the length here, or the height, and then I'm going to look at the dial indicator and see how much it deviates from 0. I'm going to bring it up all the way, then I'm going to stop. And over 2.6 inches, so it's 2.7 inches, or roughly over 2 3/4 of an inch, I have 1/1000 of an inch tolerance. So right now it looks like this, exaggerated. It looks like the plate is like that by 1/1000. So over 3 inches it's crooked by 1/1000 of an inch. So this is exaggerated because there isn't enough material here. Because my indicator shows minus, which means material is missing here. So that's the way to check squareness. If the requirement of squareness or perpendicularity is 50,000ths of an inch, I can write it down as 1/1000 of an inch over 3-inch travel. So this, again, this is the plate is minus in here, so there's a gap. Therefore, it's 1/1000 of an inch out of perfect square. Next one, I'm going to check parallelism. And again, the symbol for parallelism is this on the left, in the left column. And then I have to use a datum, and maximum tolerance is 50,000ths of an inch. So I'm going to use a datum right here, and I'm going to measure that parallelism. So this is the way to do it. I'm going to use exactly the same dial indicator, finger gauge dial indicator. And I'm going to zero it off the surface of the plate, the top of the plate, and I'm going to see how parallel is the whole length of this top to the datum edge of the surface plate. Okay. So I just zeroed my indicator. I've got dial indicator zeroed, and this is my datum surface. I'm going to drag the dial indicator along the surface all the way. So that's going to be roughly 6-7 inches, and I'm reading right now minus 3/1000 of an inch. So what it means is, exaggerated, the plate is sitting like this. So the datum is higher than the edge measured, and I can see that in the dial indicator. So I can go ahead and I can record that reading as, in parallelism, it's going to be 0.003 thousandths over roughly 7 inches of travel. So I'm well below 50,000ths again, and therefore this is acceptable. Angularity, on the other hand, you all guys know how to measure angularity. You can use universal bevel protractor. It's the one that measures in minutes, so not degrees but minutes, and then the angularity, how much it's out of, for example, 40-degree angle, that will be given to you, and you just have to measure it and stay within that tolerance of 1 degree or 5 minutes or so on, and so on. For flatness, I will show you a video how flatness is measured. Nowadays it's measured with surface gauge, and it's kind of a neat device, and I will talk about this. I'll show you a video. And for straightness, if you think of measuring parallelism but seeing if the surface is buckled or not, or basically straight, right? You can look at it at the explanation here. So we're looking if the surface is buckled out or concaved. Okay, and that's what we're measuring. So if I put my dial indicator and zero it on this surface, then I drag it along this one, this will come up to, for example, plus 10,000ths, and then we'll go down to 0 again. It means the surface up here is buckled out, but that will be acceptable if it's within 50 thousandths range. So I can write it down as straightness as 10 thousandths of an inch. So well below the 50,000 limit, and therefore this is acceptable. And the last thing I would like to mention is that the tolerances, as you saw in the example here when I was measuring the angle plate, tolerances are applied to one part only. So I was checking one part for tolerances as far as the straightness, as far as the parallelism, the angularity, or properly to explain perpendicularity, and run out. So always applied to one part only.